So let's look at how SSL actually works. So I am on Amazon.com, where I basically live. And I'm going through and looking at the different books or whatever I'm looking at purchasing. Now, you know, I could say I want to purchase this, I want to purchase that. But once I hit checkout, now the web server is programmed to know that an SSL connection has to be set up, because now there's going to be sensitive information sent back and forth, like my credit card information or some type of authentication information. So when I'm just kind of looking around the website, we don't have to set up an SSL connection. As soon as I hit checkout, then what's going to happen is the web server is going to authenticate to my browser. And how it authenticates to my browser is it sends over its digital certificate. So remember, the digital certificate, when my browser gets it, it's going to see if it's, make sure it's not expired, make sure that the unique ID actually maps with the URL, Amazon.com. And my browser is going to say, do I trust the CA who created this certificate? If it's in my trusted list, that means I have the public key for that CA. I'm going to validate the signature on the certificate. And so once I validate and I trust the certificate, now I pull out the public key for the web server. So the web server has authenticated to me with a digital certificate, and the reason is because I don't trust this web server necessarily, but I trust the CA. So once I validate the certificate, now I could pull that public key out. Now I have the public key for the web server, and I trust that this really is the public key for that web server. Now my client, my browser, will create a session key, a symmetric key, and use that public key to encrypt the session key and send it over to the browser. Send it over to the web server. So once my browser pulls out that public key, that's the web server's public key, it creates a session key. It takes the public key to encrypt the session key and send it over to the web server. Now the web server and my client, my browser, has the same symmetric key, so each side could use that symmetric key to encrypt data going back and forth. So I could use a symmetric key to encrypt my credit card information. The web browser will use it to decrypt and read that information. So this is how SSL works. And the web server always authenticates to the client, because the web server is going to require the client to authenticate in some other manner. But if you think about it, if you're sending your credit card information over to a web server, it should have to authenticate to you. So the web server will always authenticate to the client. Now, administrator can set up a configuration to require mutual authentication using digital certificates. So the web server could require the client's digital certificate, but that's pretty unusual. Usually it's a one-way, and then I have to authenticate to the web server with username and password and that type of thing. But it's always the client that creates the session key. That's important that you know that. It's always the client that will create the session key, no matter if there's a one-way authentication with digital certificates or if it's a two-way.